I see a mouse. Hey! All right, I think we're ready. Woo!
Hi.
Yes, technology.
Welcome to the year of Linux on the desktop. I'm Nadir Jiwa. I'm a senior member of technical staff at VMware. Basic means I code things. So I work on the Kubernetes project on a sub-project called Cluster API. I'm actually going to start with a demo. These have always gone wrong for me. I've done about 4 public calls. They're available on YouTube, and it's gone wrong every time. And if it goes wrong again, I have a recording I prepared earlier, as in 2 hours ago. So basically what we're going to do, talk about is why this thing called Cluster API. It's, what is it called? Why is it called that? Going to do a little demo. Hopefully it will work. I'll go through, and from that, go through how it works and some of the challenges that we've had building this thing for about 2 years now. So the problem we're trying to solve is deploying Kubernetes clusters, right? Like, it's been 5 years. You've all have your 10 years Kubernetes experience on your CVs to apply to your ads. We've all got our complicated bash. Well, not all of us. Some of us have our complicated bash scripts, Ansible, Terraform, lots of YAML. Love the YAML. Get that cluster running, and hopefully there aren't 5 million problems with it that you then need to go and fix. Search on Stack Overflow, go into Kubernetes Slack, go in Reddit, etc. to try and sort all those things out and just get working, right? Because Kubernetes is quite complicated. It's a microservice-based architecture. It's got a dozen or so services that you need to get running if you want to have a good time, and you need to get them all working, right? So we wanted to solve that problem, and we wanted to do it well, and we want to solve it once and for all for the entire community, and make it the one true way to deploy Kubernetes. So amongst the various things that you're going to put into your Kubernetes cluster are, networking, firewall rules. You need to install the right components that match that particular cloud. Like if you're using AWS, you need a bunch of AWS-specific services. If you're using VMware vSphere, maybe, you need some vSphere-specific stuff. And your bare minimum you're going to have is you're going to have your container runtime, your Docker or your containerd. You're going to have the thing called Kubler, which runs on that host and talks to that container runtime, etcd for the database. So you've got to manage that. Like, how do you manage the upgrades of etcd from Kubernetes version to Kubernetes version, right? Like, there's been some quite major changes to etcd over time. Well, at least the version that we've used to back Kubernetes has changed quite a lot. And what a lot of people do is they just don't upgrade their clusters, right? They get stuck. So I used to be a field engineer before I started doing this. I actually got fed up of doing the same thing over and over again. So it's like, I'll move over to the software development side and try and sort it out. Like, constantly visiting customers and say, oh yeah, we're on Kubernetes 1.9, which, if not familiar, that's about 3-4 years old. The support lifecycle for Kubernetes is around 6 months, right? So if you're running older than 6 months, technically you're out of support in terms of what the community says, right? You've got the API server, so that's the core sort of thing that provides the API of Kubernetes. So what is Kubernetes? It's not a container orchestration system. It's a web server which lets you write values and read them back and set permissions on them. And then other things actually provide you this container orchestration on top. One of them being this kube scheduler. So kube scheduler is an actual thing that decides where containers run in your cluster, on which node it runs. Kube Controller Manager manages the number of copies of those applications. You might have kube proxy that lets you access those services you're deploying. I mean, it's all very well. You might just deploy some YAML onto your cluster, but presumably you want to access those services. So you want kube proxy and some networking to be able to reach your external network. And you need some sort of DNS provider, right? So there used to be kube DNS. It's now core DNS now. And one of the issues is, it's still not completely solved, is how do you manage the life cycle of that DNS component itself? So yeah, how do you manage all of this? One of the tools that was generated in the community was something called kubeadm. So kubeadm was trying to give you that kind of experience that if you've ever used Docker Swarm, it's like that simple. I've got a machine, I've got maybe a couple of machines, I can SSH on them, let me run kubeadm init, and or give me, like you can do that today, you can just download kubeadm init, as long as you've got Docker running, and Kubler just installed as a systemd unit. Kubeadm init will go and give you a Kubernetes cluster, right? And it's owned by the Kubernetes project in one of the special interest groups called SIG Cluster Lifecycle. So this is how I kind of got involved into this whole rabbit hole, I guess. So kubeadm init bootstraps a single node control plane, and you can then get other machines. If they're on the same network, you can do a kubeadm join, and it will join that Kubernetes cluster. And it was always intended to be a building block, right? So if you're thinking about managing clusters as a whole, you still need to think about deploying that infrastructure, producing the images that form that cluster, setting up those firewall rules. kubeadm is not concerned about that. All it's concerned about is getting etcd running, getting the API server running, and getting the bare minimums, presuming you've got all the Docker runtime installed or containerd, and the infrastructure installed. So it's just one layer, and it's very deliberately done like that. Yeah, so just going ahead. So one of the things you might do is, Puppet, Chef, Terraform, and how do these things work? Well, you think about the overall, all of the different things that are going to form that cluster, and you write HashiCorp configuration language. You might write some Puppet, and you write a Chef to configure all of those different components. And you need to think about all of those individual things and how they fit into that greater whole. And if you haven't done it right, it's going to error, and your cluster's not going to be working, and you have to refactor it again and again. So in my previous job, I did a lot of Puppet. I wrote Puppet for like 5 years, and we had a Puppet base that we took to customers, which was probably in excess of 2 million lines, about 100,000 lines of Ruby, and then every time a customer wants a small little change, we have to start passing parameters all around the place and add new features it gets, and then our test times take 20 hours every day. So you just want to make a small change, create a PR, come back in 20 hours, didn't work. So, surely there must be a better way. So this is how we came about Cluster API. So if we are thinking in terms of layers, and each of those layers are doing independent things, then me as a person writing infrastructure automation, most of the time I don't have to think about how kubeadm works. Not strictly true, but mostly that's another meeting, that's another project. I don't have to talk to those developers all the time. I just assume kubeadm works, and I build my own automation around it. And one of the principles around Cluster API is to provide this another building block in terms of providing a flexible way to build infrastructure. And what we're doing is we're using Kubernetes to manage other Kubernetes clusters. Right, so we love Kubernetes so much, you put Kubernetes in your Kubernetes. And hence, if you've been familiar with, I think Terry Pratchett, is it? I think Terry Pratchett, he was doing a talk, I think when he was a nuclear physicist, and somebody came up to him and they said, well, repeated to him like one of the great religious stories around like how the Earth is flat and it's on. It's a giant turtle, and there's a giant disc on top of a turtle. And he's like, well, what's underneath the turtle? Well, it's turtles all the way down. So we've taken that approach, Kubernetes all the way down. And it turns out that quite a few people have sort of come along this crazy journey with us. So there's a bunch of, so I'll go through what it looks like. So, right, but there's a bunch of, the special interest group within Kubernetes that looks after Cluster API, there's a number of projects within it for each different type of infrastructure. So we have 12 today who are working on Cluster API, and then we have a number of vendors which are working on using Cluster API for their own products. Including VMware, Red Hat, Microsoft has made huge investment recently. And what we're talking to cloud providers who are building their managed Kubernetes services on top of Cluster API. So people are beginning to see that this is probably the way we should do things today. So just that's all theoretical and maybe a bit marketing. So maybe I should just pull up why we might want to do something like this. And I'll also kick off the demo as well. Right. All right. Okay, cool. So I'll start the demo first. So down here is a part of Cluster API running, and it's the AWS provider. So there's different, we call them infrastructure providers for each of these things. So what I'm going to do is hopefully create a cluster. So to do that, we have a CLI tool called Cluster Cuttle. Hands up if you think it's kube cuttle, and who thinks it's kube control? All right, fine. All right, there's a tool called Cluster Control. And I'm going to put this down. Oh, right, okay. We've got some beautiful YAML coming up. And where is that window gone? Who knows? Oh, yeah. There we go. Right. So, what I've got here are two exactly the same clusters. That's not what I meant. Doesn't matter. So, anyway, right. So, a cluster, as all things in Kubernetes, it's beautiful YAML. So, in this, we have a cluster. We're going to say it's going to use a certain network, 192.168.0.0/16. And one of the things is, so this is a new change that we did in the last version, and we're carrying it through, is you reference more YAML to represent the different types of cluster that you're building. So this cluster is going to use kubeadm for its control plane. So not every one wants to use kubeadm. So it's a default implementation. So for instance, OpenShift uses its own orchestration system, and we allow people to swap different implementations out, right? So kubeadm is what you get out the box, or what will be supported by the SIG cluster lifecycle. And we're going to create an AWS cluster. So we have a cluster object, and it references this other AWS cluster, and the thing we put in it are the things which are special about AWS. So a region is not a concept, is a concept only in AWS. And also the SSH key name, so it's part of EC2, it's the EC2 specific reference. So we define that inside the AWS cluster object. And we have just YAML to fill this out. So this is why you should use the CLI tool to do this for you. One of the things you'll see is, which I'll go through in a minute, we have this machine deployment. It's currently got a replicas of 0, which is interesting, maybe. And just some more templated stuff. I'm just going to move this slowly back, because I think there's some credentials hiding in there, in somewhere else. One of the other tabs, which I should close. And very briefly, I'll just show you a vSphere cluster. So the beginning looks exactly the same. And we have some other bits in this. So we have a HA proxy load balancer, my SSH public key, and like the VMware specific stuff. So what this allows you to do, so what we want to allow is you can install different providers, and if you want to go down that multi-cloud route, not everyone wants to, but a lot of organizations do want to be able to provision clusters across different types of infrastructure, then it gives you the ability to provide a consistent way of managing it. Right? Rather than having developers have to know AWS SDKs or Go vMommy, for instance, which is not the greatest. Right? VMware APIs are not... Yeah, well, you know, they're an evolution, right? So, but you don't want to give that to developers, right? Like, that's not, developers shouldn't have to care about how the infrastructure is being provisioned, right? They shouldn't need to know what those individual objects are, what those individual constructs are. You want to be able to abstract that away. So what Cluster API gives you the ability to do is to give you that abstraction. So what I'm going to do is actually just going to apply that. And this will go completely wrong. So I'm actually doing a different AWS account than I normally do. It's my personal one, so it's going to cost me money as well. So right, just get through that. So what does it look like? So there is this interesting concept. So you need a Kubernetes cluster to start off with. So what I'm running on my laptop is something called Kind. It's called Kubernetes in Docker. So it's a CLI tool, and because I use Linux, and Docker's pretty fast on a Linux system, Kind can create a new Kubernetes cluster in about 30 seconds, just on your laptop. So it's really good just for spinning up test clusters, throwing them away. It's really great. If you're developing for Kubernetes, highly recommend you check out Kind. It's made a huge difference to the way develop software on Kubernetes. So you need a management cluster, and it needs to run these controllers for each of the different providers. It needs to run cluster API itself. And then this management cluster, so ideally you will have it running somewhere else on the cloud. So you can use an existing Kubernetes cluster. You can use GKE to manage vSphere or AWS clusters if that's how you want to do it. You can use Amazon EKS to do the other way around. And you can use VMware Tanzu Mission Control to also do that. So you need a management cluster. So one of the things we're doing in the latest version called V1 Alpha 3 is the ability to start off on your laptop and move it to a proper cluster. It's work in progress, so I'm not demoing that today. This is literally straight out of the oven yesterday, this stuff. So the things that we have in Cluster API is a bunch of abstractions, or YAML objects, if you like, that represent clusters and machines. And then we also have, much like other things in Kubernetes, where you have the concept of a pod, you have a concept of a replica set, which controls the number of copies of those pods. We have a machine set that controls the number of copies of that machine, or how many machines of the same type or the same configuration are created. Then machine deployment, which is able to swap, so you can do upgrades along the way to be able to scale up and scale down and refresh those machines. Machine templates, so literally just exactly what it says. We also have components around which are more internal to Cluster API, so you don't directly have to interact with them, but they're there to make Cluster API work. So Bootstrap configurations, and we have a new object called the control planes. This manages doing upgrades of Kubernetes from one version to another, and machine health check. So Joel in the front row has been working on. So that helps us do remediation, right? Like, so you can set health checks on nodes. So you can say this machine should have this behavior, and if it's not having this behavior, there's something wrong with it, and you need to kill it, and we need to get it replaced. That's exactly what this machine health check does. So it's a really powerful tool that's coming into this new version. So if you're not familiar, so Kubernetes 101, so is how things work. Oh, what have I pressed there? Jesus. Oh, there we go. Right. Oh. Okay, so Kubernetes, everything is a controller. So the idea of control, it comes from robotics theory, control theory. So this idea is you have a simple loop, and you're constantly checking the state of the world, and you're making changes to the world to make it more like what it should be. So you declare your YAML that declares your intent, and controllers continuously act to reconcile the state of the world with your intention. So this works differently to things like Terraform, right? There's an inherent concept of retrying and trying again. If something doesn't work, fine, we'll come back and we'll do it again. We'll keep retrying until it's in the right state. And it turns out it's quite a powerful thing. We use it in thermostats, we use it in lots of applications today in robotics, work along this line. So it's quite a powerful tool. Theoretically, it's quite simple to reason about, because you're only concerned with making one thing happen. It's not strictly true when we're talking about the cloud. And we just retry. So you don't have to then think about the entire state of the world. How does this bit of Terraform relate to this other module? You're just saying, make this one thing happen, and keep retrying until it happens. So we have that with machines. So you declare a machine, your infrastructure provider controllers go, well, oh, a new machine has appeared. I don't see it. Let me create it. So we'll go and create that machine if it doesn't exist. And then we have the machine set. So you set a machine set. You say, I want 5 of these, and there's only 4 of them. The machine set controller goes, oh, there's only 4. There should be 5. So I'll create another machine. But it does nothing else. It doesn't talk to AWS, for example. That goes back to the AWS machine controller that says, the machine set has created another machine. And so it says there's now 5 machines. I only see 4, so I need to go and create this other one. And the machine deployment works the same. So we'll say, it will look at 2 different machine sets, go, well, change the version, there's 5 of the old one, there's 3 of the new one, and you want 5 of the new one. So we need to kill some of the old versions, and we need to create more of the new version. So the machine deployment controls machine sets, and machine sets control machines, and then the infrastructure provider will look at those machines and create the actual infrastructure. So this is how everything works in Kubernetes. From when you're developing applications, you're creating deployments. Deployments control replica sets control pods, and pods actually then get attached to nodes, and then finally you end up with your application saying, hello world. I mean, that's just me. You probably have more important and probably revenue generating things. So in our we run Alpha 3 architecture, so we have lots of different controllers doing lots of different things. We have the infrastructure provider controllers. We have the machine actuator that's provided by Cluster API Core, the cluster controller, Bootstrap provider. So these things you shouldn't need to necessarily worry about as an end user, right? So use this new CLI that I'm developing called Cluster Cutter. I'll show you where those are. Some of the documentations are work in progress or is yet to be written, but it will be there in the next week or two. And yeah, so the idea is this: we have this management cluster that's managing multiple clusters across your estate, wherever that is. So one of the things you can do is, because Kubernetes has a rich permissions model, has a rich role-based access control, is you can start to delegate the management and creation of clusters down to different development teams, right? So you can say, this development team is allowed to create AWS clusters. You might have your own little controllers that say, well, make sure they're not loading up the biggest instances with all your GPU resource and spending all our money. Like, you can do that, and Cluster API doesn't care about that. It's just going to see that definition, and you can check that as it goes into the cluster. So you can use tools like OPA or Gatekeeper or write your own admission controller, which are just webhook services say, is this thing allowed or not, right? So it's a different way of, rather than getting developers to write Terraform, just delegate access to this management cluster itself and let them be able to manage what they want. And demo, so just check how that's going. So something failed. There we go. Oh, no route to host. All right, so the internet died there. What a shame. So I'll just quickly, I've got a recording. I can click normally. Right, play it at super speed. So it doesn't come out well because the nested team-ups in ASCII cinema doesn't work particularly well.
Could you speak back into the microphone?
Yeah, sorry. So it doesn't work particularly well because ASCII cinema doesn't work brilliantly with tmux. But basically what happens is we have this one machine. So that cluster that I generated, first of all, what happens is Cluster API creates this one control plane instance. And we have these different coordinating controllers just waiting for things to happen. So no more machines will be created until the control plane will be ready. And here I've actually accessing this new cluster already. So we've got kubectl get nodes, which gives me the status of those nodes. And now the thing that I did is I actually scaled up this replica set, this machine deployment from 0 to 3. It depends on what the order is. Yeah, there we go. It's from 0 to 3, so it created 3 new AWS instances. This happens in the space about 30 seconds, really. So once you've got the control plane ready, you can scale up and down pretty rapidly. And that was it, because it played at 10 times the speed. So that was that. I knew that was going to happen. As in, no internet. And I messed up my slides, so that's fine. Right, I think I'll just stop there, I think. So we've had some of the challenges that we've had doing Cluster API is, I think one of the things that's been really challenging for me as someone who works on AWS is you have to figure out how AWS works internally a lot. Because unlike Terraform, we're constantly retrying things. So if something doesn't work, we have to go and retry it. We also have to assume that things are going to crash constantly, and how can we pick up from where we left off in case something crashed? Or like somebody moves these objects from one cluster to another, how do we make sure everything works? So you end up doing a lot of testing of what, does this call to AWS, is it eventually consistent, or does it happen immediately? If I send it twice, what happens? Is it going to create 2 of these things, or will I just have the same result that I originally intended? There's some interesting things. So we are actually using pretty much everything in Kubernetes, so we're finding out a lot about what's going in Kubernetes. So we're probably 3 minutes. It's 9 o'clock, so I will stop now. So there you go.
Thank you. That was really good. Thank you for that. So for the stragglers who are left, I think we can go to the pub, we're going to the draft house, because I don't think we've got time for questions. I really think that the Sainsbury's people want to be like, can you please make your escape? So sorry?
It's available now. The latest version with all the new CLI tooling will be is in release candidate right now. But we need to write the documentation. So end of the week.
Coming at you this spring. Right, thank you everybody. See you next time.